Hey everybody, today we are going to talk about similar figures. Similar figures are figures that have the same shape but not necessarily the same size. So here we have two figures. Okay, they're similar. And this is a similarity statement right here. It says triangle ABC is similar to triangle XYZ. Okay, what does that mean? Well, if you'll notice, all the angles are equal. Okay, so angles determine shape. These are the same shape because all the angles are the same. Okay, but notice the sides are different. 12, 21, 18, 8, 14, 12. Okay, so, but if you look at the proportion, so AB is 12, XY is 8. BC is 18, YZ is 12. AC is 21, XZ is 14. So if I take these three fractions and I reduce them all, they all reduce to 3 to 2. Okay, so the sides of this triangle are proportionate to the sides of this triangle right here. So when the angles are all the same and the sides are proportional, you have similarity. Okay, so here it says all the angles are equal and all the sides are proportional. And so, we'll put this nice rainbow thing circle. You should know that. Okay? All the angles are equal, all the sides are proportional, therefore the two triangles are similar. Okay. Which rectangle is similar to rectangle A? So, if it's a rectangle, that automatically implies all the angles are 90 degrees. Otherwise, it would not be a rectangle. And that's true on all of these. So I don't have to worry about that. What I need to check is to make sure that the sides are proportional. Okay, so if I check A and B, 3 is to 2, as 6 is to 6. Well, that's not true. This is 1.5 here, and this is 1, and that's not equal. So this cannot be similar to that. So we could say A is not similar to B. I don't know if that's really a symbol, but it's not similar. Okay, so now let's check C. So we could say 3 is to 2, as 6 is to 4. Okay, if I reduce 6/4, I get 3/2. So the sides are proportional between A and C, so we would say A is similar to C. So pretty simple. And that would also tell us that C is not similar to B because A wasn't similar to B. Okay, so the triangles are similar, find X. Okay, so here's what you got to do. You've got to find a proportion between these. So 9 goes with 6 here. And since the big one's on top, the big one has to go on top over here. The small one has to go on the bottom. Okay, I just need to solve this proportion. So remember, I can cross multiply. 6x equals 8 times 9. So 6x is 72. And when I divide by 6, I'm going to get x is 12. Okay, so this side has to be 12 meters, and then that's similar. If it's anything other than 12, it's not similar. Now the tricky part comes, if I took this and I flipped it over and maybe rotated it, you got to make sure you match up the right sides. You got to make sure that the corresponding sides are the ones that you compare. Okay, the two trapezoids below are similar. Find the length of H. Okay, so we've got 3.75 is to 15 as H is to 12. Okay, so I'm going to solve this. Now, the other way you can do this, you can do it all in one step, is anytime you have a proportion, you take the two diagonal numbers and multiply them together and divide by the other one. So this would be 12 times 3.75. Probably better if we wrote it like this. Divided by 15 is going to be h. And of course I don't have my calculator here, so I'm going to have to do this by hand. 3.75 times 12. So that's going to be 4.5. So h is 4.5 divided by 15, which I can do that in my head because 15 will go into 45 3 times, so that'll go in there 0.3 times. So h must be, that's not right. Yeah, it is. 0.3. And that would be inches. Boy, that doesn't seem... .75 is to 15. The small one's on top on both of them. Did I multiply this right? 10, 14, 15, 6, 7. We did a 0, 5, 7, 3. Oh, there's my problem. I got my decimal in the wrong place. So this is 45. So this is 45. This is 3.0. So 3 inches. Okay, so there you go. Okay, so here's your assignment. You're going to do 1 through 25 odd, not a lot of problems. We'll do those in class, and I will see you guys next time.